Hello everybody, welcome into another lesson. So today we are going to convert non-terminating repeating decimals into fractions. And this is probably going to seem like a little pre-algebra review, but this is a good one because this may come up again in future courses. So here we're given 0.4 repeating. We want to convert this into a fraction. So here's how you start. You're going to take that 0.4 repeating, we'll let n, use a let statement, let n equals 0.4 repeating. Alright? Now, how many decimal places appear to be to the right of the decimal? I know technically it's infinite because that repeating 4 means the 4 goes on forever and ever and ever and ever, but we have a bar here, we'll just say it goes 1 decimal place, right? In order to move the decimal place 1 to the right, we have to multiply by 10. So if you do that, you'll get 4.4 repeating. But what you do to the right, you gotta do to the left. So you take n times 10, you'll get 10n. So now we can say let 10n equal 4.4 repeating. So once you've got your let statements down, next thing you're going to do is take your bigger number, take your 10n, which is equal to 4.4 repeating, and then you'll do minus your n, which is equal to that 0.4 repeating, and then now we'll just do some simple subtraction. 10n minus n, that's simply 9n. So then we have 4.4 repeating minus 0.4 repeating. Well, if you have the same number repeating minus the same number repeating, the repeating number is gone. So you can now pretend that 0.4 repeating in both of these don't exist anymore. All you have to worry about is 4 minus 0, which we know to be 4. Last but not least, what you need to do is you need to solve for n, which will give you the fraction you're looking for. Solve for n, I divide both sides by 9, and would give me 4/9. So the fraction we're looking for is going to be 4/9. And if you don't believe me, feel free to put 4/9 into your calculator. You should get 0.4 repeating. Alright, so there's that one. Now, what about 1.15 repeating? So we have the number 1.15 repeating, okay? Well, again, what we want to do is set up a let statement. So we're going to let n equal that 1.15 repeating. Now, how many decimal places are to the right of the decimal place? That'd be 2. So in order to move the decimal place to the right 2 decimal places, you have to multiply the right side by 100. If you do that, you'll end up getting 115.15. Okay? But what you do to the right, you gotta do to the left. So if you take n times 100, you'll just get 100n. So 100n, we will let 100n equal 115.15 repeating. Now you're just going to take your bigger number, that 100n, set that equal to your 115.15 repeating. Do that minus your n, which is equal to the 1.15 repeating, and you have a simple subtraction problem. So 100n minus n, that would be 99n. So now we have 99n is equal to the right side. Well, notice we have a 0.15 repeating minus a 0.15 repeating. So the repeating numbers are gone, those no longer exist. Now you just got to focus on 115 minus 1. Well, that's going to be 114. So now we have 99n equals 114. And to get the fraction we want, just solve for n. n would equal 114 over 99, which actually does reduce further because 114 divided by 99, both of those have a common 3. You divide 114 by 3, you get 38. Divide 99 by 3, you get 33, which reduces no further. So remember, when working with a fraction, always remember to reduce it into the simplest terms possible. That's one way you could write your answer, is as an improper fraction. The other way is as the mixed number of 1 and 5/33. So you could also write it as the mixed number of 1 and 5/33. Both of those will give you the same result. All right, let's move on to a bit of a harder one here. So, what is one to do if you're given one like this? Negative 0.28, but only the 3 is repeating. What do we do in that situation? So we have negative 0.28, only the 3 is repeating. There's a couple things we need to do here. First, you want to split this up here. Forget about your negative sign. Always omit your negative sign to start with. Just focus on that 0.283 repeating. The negative sign will come back into play at the end. Isn't it true that 0.28 with the 3 repeating, isn't that the same as 0.28 plus the 0.003 repeating? Isn't that the same thing? You would end up having 0.28 plus 0.003 repeating. So not only for the time are we going to omit the negative sign, we're going to forget all about that 0.28 for a minute since it's not a repeating decimal. We only care about this 0.003 repeating. Now, what we want to do here is we're going to focus on that 0.003 repeating. So we will let n equal to 0.003 repeating, okay? Well, that's all great. We've established an n. Here's the problem. We still have yet 2 numbers that don't repeat and the third number that does. Well, what do we do then? In general practice, it is absolutely best that the repeating number is immediately after the decimal, which right now it's 3 places after the decimal. We want to make this 1 place after the decimal, which means we would have to multiply this number by 100, wouldn't we? So if we do that, we multiply the number by 100, you would get 0.3 repeating. So you'd have to multiply the n by 100. We'll let 100n equal 0.3 repeating. Now we actually have something we can work with. Let 100n equal 0.3 repeating. Now that we have the number as the repeating decimal immediately right after the decimal, the repeating number is immediately after the decimal, it's easy now to multiply 1 more decimal place and get a whole number here with the decimal. So you move it to the right 1 more, you got to multiply by 10, you would get 3.3 repeating. Okay? But we have to multiply the 100n by 10, that would actually be 1000n. So we would actually let 1000n equal 3.3 repeating. So forget about everything above here for a second. What you're going to do now is take the bigger of these 2 numbers. You'll take your 1000n equal to 3.3 repeating minus your 100n which is equal to that 0.3 repeating. Alright, now it's a simple subtraction. Well, 1000n minus 100n, that's 900n, is it not? 900n is going to be equal to the right side. The reason we set it up this way is, and have the repeating numbers immediately to the right of the decimal places, because we want to perform subtraction and ultimately get rid of those repeating numbers. That's the only way to do it. Now we can do 0.3 repeating minus 0.3 repeating. The repeating numbers are gone. Now you only have to worry about 3 minus 0. That's 3. So now you solve for n to get your fraction. N would equal 3 divided by 900, or it would reduce to 1 over 300. And it turns out your n, the fraction you're looking for, is 1 over 300. That's just the beginning of it. The 1 over 300 only answers this part, the 0.003 repeating. And if you're not sure what 1 over 300 is, punch it into the calculator. You'll get 0.003 repeating. So we've only answered one part of it. Now it's time to take this 0.28 plus the 1 over 300. Well, what is 0.28 as a fraction? That's 28 hundredths, right? You'll end up having 28 hundredths plus 1 over 300. Well, we're almost there. We have 28 hundredths over 1 300ths. Well, we need to make these, of course, the same denominator. We have to multiply the first fraction, numerator and denominator, by 3. If you do that, you'll get 84 300ths plus 1 300ths, which when you add those, you'll get 85 300ths, which would reduce to 17 60ths. And 17 60ths reduces no further. The last thing is, don't forget your negative sign from the beginning. The actual fraction you want is negative 17 60ths. So the decimal form of this equation is this number is negative 17 60ths. And if you don't believe me, just punch it into the calculator, you'll get exactly that number. So negative 17 60ths would be the answer to this. And I have another problem just like this, but it shouldn't be quite as bad. Alright, what if we have 2.3 with only the 9 repeating? So we have 2.3 but only the 9 repeats. 2.3 with the 9 repeating. Well, this is a similar type of problem. What you should do now is split this up. We have no negative sign, so that's working in our favor. Isn't it true that 2.3 with a 9 repeating is the same as 2.3 plus 0.09 repeating? Wouldn't that be the same thing? Whenever you have a decimal where the repeating number is not immediately after the decimal place, you kind of want to split these up into a way that makes sense. Because ultimately we want to single out the repeating decimal, do we not? Well, next thing you should do, we'll forget about 2.3 for a minute. We're only going to focus on that 0.09 repeating. So we're going to let n equal that 0.09 repeating. Now keep in mind, the goal is to ultimately get rid of the repeating decimal. That's not going to work to try to solve for a fraction. Well, here's one problem. The repeating decimal is not right after, the repeating number is not immediately to the right of the decimal. We need to make it immediately to the right of the decimal. In order to do that, you would have to multiply the right side by 10. So if you do that, you now have 0.9 repeating, which means you got to multiply the n by 10. You'll get 10n equals 0.9 repeating. So we'll let 10n equal 0.9 repeating. Now we actually have a number we can work with. 0.9 repeating, the number is immediately to the right of the decimal. The repeating number is, okay? Well, what we have now is we're going to have to move the decimal place to the right one more to be able to get a whole number with a decimal, so we can ultimately do the subtraction and cancel the repeating number. We got to move the decimal place to the right one more, so we have to multiply by another 10. If we do that, you'll get 9.9 repeating. So now you have 9.9 repeating. You multiply the 10n by 10, you actually get 100n. So we will let 100n equal 9.9 repeating. Okay, so now that we've established a whole number with the decimal, and then we have the 0.9 repeating, we'll take the bigger number, that 100n, which is equal to that 9.9 repeating. We'll take that minus our 10n. That's going to be equal to 0.9 repeating. Well, what we have here is we have 100n minus 10n. That's going to be 90n. That'll give you 90n. And then you just got to focus on, you got 0.9 repeating minus 0.9 repeating. Well, that's just basically going to be 0. Now you just got to worry about 9 minus 0, which is 9. So now we just want to solve for the n, divide both sides by 90. You would get n equals 9 over 90, which is 1/10. Well, hang on a second. Doesn't 1/10 equal 0.1? Well, yes. Here's the thing. With this decimal converting to a fraction, the idea is that 1/10, that 0.0 with the 9 repeating on and on, the 9 keeps going on and on, it's so close to 1/10 or 0.1 that this would in fact round to 1/10. That's the idea. So we can stick with the n being 1/10 for that. Now all you have to do is take your 2.3 plus your 1/10, which we know the 2.3, that's the same as 2 3/10 plus 1/10, which is going to be equal to 2 4/10, which is roughly the same as 2 2/5. That is the closest we can get. Now 2 2/5, this would actually round to 2.4, which pretty much works because that 9 goes on forever. You round it in any way, shape, or form, no matter what decimal place it's in, it's going to throw it to 2.4. So this also demonstrates the imperfections of converting these decimals into fractions sometimes. It's not 100% perfect all the time. They can get a little funky, but it's darn near 2 2/5. It's infinitely close to 2 2/5 without actually hitting it, which that is another topic for a calculus course. When we get into limits, we will discover all about how close numbers can actually get without hitting it. But I'm not going to throw calc at you today. No way. Back to some better numbers. What if we just had 0.07 repeating? So this time we have both numbers to the right of the decimal are repeating. So there's some good news. Well, we can immediately proceed with our end statement. We will let n equal that 0.07 repeating, right? Well, now, since the repeating digit is immediately to the right of the decimal, we can go ahead and proceed to trying to find a whole number that will take care of ultimately getting rid of the repeating decimal. We need to move the decimal 2 places to the right, which means we got to multiply by 100. If you do that, you get 7.07 repeating. But what you do to one side, you got to do to the other. You'll have 100n is equal to 7.07 repeating. So we'll let 100n equal 7.07 repeating. Now we'll just do 100n equal to 7.07 repeating minus your n, which is equal to 0.07 repeating. If we do that, 100n minus n, that'll give you 99n. That would be equal to, well, the 0.07 repeating minus 0.07 repeating, those go away. Those are gone. Now just focus on 7 minus 0, that's 7. So you have 99n equals 7. Now we got to solve for n. N would equal 7/99. So this would largely become 7/99. That would be your fraction for this, and it doesn't reduce any further. So 7/99 would be your answer. Only got a couple more here. I have 2 more problems. We'll do 2 more problems, then we'll call it a day. So I have negative 1.36. We got negative 1.36 repeating. I forgot to put the bar above the 36. So we have 1.36 repeating. That's negative 1.36 repeating. Again, whenever you have a negative sign, ignore it for a minute. Forget about the negative. So we will let n, since the repeating numbers are immediately to the right of the decimal, we can proceed with our end statement. Let n equal that 1.36 repeating. Now, how many decimal places is it to the right? We have 2 decimal places. We want to get a whole number, so we can do subtraction and get rid of that repeating decimal. So we need to move it to the right 2 decimal places. Multiply by 100 to do that. You would get 136.36 repeating. So you multiply n by 100, you'll get 100n. So now we will let 100n equal 136.36 repeating. So then we'll do 100n. That'll be equal to 136.36 repeating minus your n, which is going to be equal to 1.36 repeating. Okay? So 100n minus n, that's going to be 99n. That's going to equal, well, the 0.36 repeating minus 0.36 repeating, those disappear. You just have to worry about 136 minus 1. That'll give you 135. Now what you're going to have to do, divide both sides by 99 to get your fraction. You'll get n is equal to 135 over 99, which in these type of problems, you really want to get a mixed number. It's kind of bad form to leave it an improper fraction. You want to make this a mixed number. So let's see if we can reduce this any further first. Can we reduce this any further? I think 135 is divisible by 3, yes. 135 is divisible by 3. You get 45, but 99 is also divisible by 3. But guess what? The 45 and 33 are divisible by yet another 9. By another 3. 45 divided by 3 is 15. 33 divided by 3, that's going to be 11. So now we have 15 elevenths. So we got that reduced down to 15 elevenths. Well, 15 elevenths as a mixed number is 1 and 4 elevenths. And it looks like we're almost done, except we forgot the negative sign in the beginning. Don't forget your negative sign. Once we put our negative sign in front of it, we have our answer, negative 1 and 4 elevenths. Throat getting dry, excuse me. One last problem and we are done for the day. Alright, so what about negative 2.3 repeating? Negative 2.3 repeating. First thing you're going to do, once again, forget about your negative sign. Don't even worry about it. You have here, the repeating number is immediately to the right of the decimal place, so we can proceed with our n statement. We'll let n equal 2.3 repeating, because we're forgetting about the negative sign for just a minute, but don't forget it for your final result. Now, we want to find another number, so when we do the subtraction, we can get rid of that repeating decimal, and we have one number to the right of the decimal, so we need to move this to the right 1 decimal place to do that, which means you got to multiply by 10. If you multiply by 10, you'll get 23.3 repeating. Multiply the n by 10, you get 10n. So we'll let 10n equal 23.3 repeating. Now you'll just take your 10n, set that equal to your 23.3 repeating, minus your n, which is 2.3 repeating. So 10n minus n, that's going to simply be 9n. That'd be equal to, all right, 0.3 repeating minus 0.3 repeating. The repeatings go away. Just worry about 23 minus 2 now. That'll give you 21. Then you'll get your fraction, which would mean n would equal 21 ninths. But 21 and 9 both have a common factor of 3, so we can reduce this further. You'll get 7 thirds. Which, as we know, 7 thirds as a mixed number is going to be 2 and 1/3. And we got the final number, but we got to tack on a negative sign because the original number had a negative sign. So the answer to this is the fraction will be negative 2 and 1/3. So that's really it for converting these repeating decimals into fractions. Next lesson, we are going to talk about irrational square roots. We're going to really dive into square roots, also known as radicals. We will get into those. So I hope everyone has a good night. Take care.